Aufnahme starten. Ja. Und dann so das Szenario. Okay. Yep. One more word in. We have to. Oh, it's fine. It can zoom in this one. Right, now zoom. We're gonna use this one. Yep. What is the เรื่องอะไรนะครับเดี๋ยวครับผมกำลังเซตอยู่นะเดี๋ยวตอบให้ครับ It's the right in what is that circular class attendance this one right in 604 in it's the class attendance score oh yeah. Oh, the wrong code. Okay. Yes. Okay. In เรื่องอะไรนะครับF I L D side data and then just stream how is staying in. Yep. Okay. I'm not sure whether you ใช่ครับ ได้ครับไม่เป็นปัญหาครับพิมพ์มามันมี2ช่องนะครับ YouTube นะครับมันจะมี YouTube ตรงๆกับกับจากซูมไป YouTube ครับโอเคไหมครับครับคุณเลือกเอาเลยครับผมพยายามเปิดช่องทางให้คุณมากที่สุดเพราะว่าคุณจะได้สบายๆครับ I have to close the microphone here okay all right and yeah good morning everybody welcome you to the SCI33205 it's actually physics number 4 right we're gonna see what's going on so that we would not waste our time so much. We're gonna go ahead with our lecture notes immediately. All right. 511. So I need to take care of to that. To go to this channel. This channel. Okay. Not sure. Someone is waiting for. Oh yes. Okay. All right. This is the Zoom to YouTube. Okay. Yeah. Weเช็คชื่อใน YouTube ได้ครับได้ครับแคปเจอหน้าจอใน YouTube ส่งมาในไลน์กลุ่มด้วยเผื่อการพลาดผมหาไม่เจอครับโอเคso here we have the okay still more 5 people yes still more 2 people one more กันพลนะครับผมได้รับอันนั้นแล้วครับแจ้งไปที่ครูเมื่อคืนแล้วนะครับก็ไม่รู้ว่าเขาพร้อมแก้ให้คุณแล้วหรือยังครับแต่ว่าก็แจ้งให้คุณแล้วครับเข้าใจครับคุณพิมพ์ชื่อโอเครู้สึกเป็นสุภสิทธิ์นะครับตามสบายเลยครับผมไม่รู้ว่ามันจะกระตุกหรือเปล่านะเพราะว่าดูเหมือนว่ามันวิดเก็ตบอกว่าวิ่ง error นะครับใน YouTube ครับแต่ว่า YouTube จะเป็นช่องที่เห็นหลายมุมมากที่สุดนะแล้วก็ถ้าเสียงใน YouTube ไม่ดีไม่มีอะไรก็แจ้งผมได้เลยครับโอเค let's continue our topic so that we would not waste so much time I want to go quickly there it's 8มีคนรออยู่ไม่เลยไม่มีคนเข้านะครับถ้าผมอยู่ตรงนี้แล้วผมจะมองไม่ค่อยเห็นนะครับyes I have to share the screen วีรพัฒน์ share the screen right okay I hope that everything is fine the microphone should work perfectly right okay for M604 we arrive at the magnetic force of 2 conductors right yeah. เอาจอนี้ขึ้นไปให้ด้วยนะครับ ที่ YouTube นะครับคุณจะได้เห็นนะครับYouTube มี2อันนะครับจากซูมไปนะครับถ้ามัน YouTube ตรงๆมันกระตุกแต่ว่า YouTube ตรงๆเนี่ยรู้สึกว่ามันจะแม่นที่สุดนะครับคือภาพจะชัดที่สุดครับแต่มันจะมีกระตุกผมยังแก้ปัญหาเน็ตไม่ค่อยดีนะครับที่นี่มี 5G เฉพาะของ True เท่านั้นนะครับผมซื้อซิม AS มาด้วยนะครับแต่ว่ามันไม่เวิร์ก 5G นะมันขึ้นแค่ 4G นะครับที่นี่นะครับโอเคokay let's continue our story we arrive at the page 90 6, right? It's something about the magnetic force between two conductors, which is an extension to the typical the former topic, which is the force acted on the long straight copper wire, right, or the conductor. Okay. สุภสิทธิ์นะครับ okay. Yes, this one will be a little bit more complicated. Okay, it includes something more. Okay, with respect to the former topic. In the previous topic we have only a single long straight copper wire, right? But right now we have both. We have two long straight copper wire. And of course, each long straight, each conductor can have two possibilities, okay, two possible ways of current movement or flow, right? And the current movement plays also a significant role in the direction โอเคครับ K นะครับพิมพ์มาครับin the direction K รู้สึกว่าเป็น Ken หรือเปล่ากสิดิตนะผมอยู่คุณนั้นผมเริ่มจำชื่อได้ครับโอเคplays the current movement or current direction in each conductor plays a significant role whether the force will be attractive force or the compelling force. Okay, the force that try to bring both conductors to be away from each other. Okay, the compelling force. Okay, and I would like to give first the introduction to this topic. It includes also the effect of the Biot-Savart formula. Okay, maybe you have seen earlier. Okay, everything that we have seen before, okay, is going to be included more and more in the succeeding section, and especially this one. Okay, yeah. From Plata, what happened? Okay, พิมพ์ชื่อกันมานะครับ Okay, yeah, we consider the two long straight copper wire. Okay, and we have one of that on the upper part. Okay, and ผมเดี๋ยวขออนุญาตต่อเมาส์ซ้ายดีกว่าครับเพื่อว่าจะได้ใช้งานอย่างคล่องแคล่วนะครับแล้วชี้เมาส์ให้คุณนะครับทั้งสองช่อง So right, we're gonna use this one. Okay, right. We have the upper conductor. Okay, it makes of the same type of material. The lower one as well. Okay, according to the same color of the bar or the conductor you have seen here. And the one important thing that you need to pay attention is the symbol. Okay, here the dot symbol, as I have mentioned it earlier to you. Okay. The dot one represents the head, okay, the front view of the arrow or of the vector, and the cross side, okay, represent the X side or the cross side represents the tail or the rear part of that arrow or of that vector, right? That's typical way in physics. Okay, if we draw the arrow with those with that amount of arrows, okay, it's gonna be very complicated and it's not easy to understand. Okay, this is the effect of the magnetic field. Okay, the blue one or the cyan color of those dots and cross eye represent the magnetic field lines that is induced by here this is the magnetic field lines as you have seen represent the field line that is induced by this copper, this long straight copper wire, okay, the lower one. This is what you may have seen earlier from the it can be said it's Ampere law or Biot-Savart law. Okay, Biot-Savart law will tell you how to get the magnitude of the induced magnetic field. Okay, the strength, the B. Okay, but the Ampere law is involved both the right hand rule. Okay, the right hand rule will give you the direction of the induced magnetic check on โอเคครับขอให้ด้วย the right hand root, okay, if you lay your thumb according to the direction of the if you lay your thumb according to the direction of the current movement, okay, you will get the direction in the direction from your remaining 4 fingers, and that will be direction of the induced magnetic field lines. Okay, and of course at the lower part, lower conductor, there will be magnetic field, okay, which is a distance, okay, from which is the result at the distance from the magnetic field caused by the lower conductor. Okay, it's pointed or directed in this way. Okay, out of the lecture note. Okay, to us, but it's they write it in another different angle, so it is directed in this way. Okay, and of course from the topic that we have seen before, we use F equal ILB, right? You start first from the direction of vector L, right? Which is the same direction as the current movement. Okay, in the second, we are now considering the force, okay, that will happen on the upper at the upper conductor. In the first vector is I, right? Sorry. In order to determine the force from the lower conductor, okay, the magnetic caused by the lower conductor, we have to use again the same expression FILB, okay, in order to determine the direction of the induced force, right? But B is the magnetic field from the lower one, okay, but the force is the force that will take place at the upper conductor. Okay, อินเทอร์เน็ตผมเป็นอะไรครับมัน security no we're gonna use ประภาวิทย์ครับไม่มีปัญหาครับสู้นะครับมันชอบเข้าของมหาลัยครับซึ่งมหาลัยมันไม่แรงครับ okay, yes, the first vector is the vector L, right? The vector L, and of course the vector L is gonna be pointed in this direction, right? This is the vector L, okay, according to the direction of the current movement, right? In this one, okay, the vector L. The second vector is the induced vector caused by the lower conductor, but here, okay, the vector B that is pointing in this way, okay? And of course we can draw it right now. Vector B right here, right? Okay, that's the vector B, and then yeah, you have to curve or turn your four fingers, right, from vector L to vector B in this direction, and then you will get the outcome, which is the induced force caused by the magnetic field from the lower conductor right here, okay? And that's the first force, okay, we can get from the whole scenario. But actually there will be also the force, okay, exerted on the first conductor or the lower conductor as well, because these conductors can get the effect of the magnetic field from the upper conductor as well, okay, because there is current movement in the upper conductor, okay, and the upper conductor will generate the magnetic field line as well, and that field line will go and it will cross the lower conductor as well, okay. But first, if we draw everything, that will be difficult because everything will be complicated. So they just show only in this book, they just show only the force, okay, that happens at the upper conductor only, okay. Let's move to the next one, okay, which is the full version, okay. You understand the cross and dot symbol, right? It's the tail and the front view of the magnetic field line, okay. Now let's consider the that's the same thing. You have the sorry for that. You have it's the same kind of what we have seen before, okay. This figure has no big difference from the previous figure, and I don't understand why we could not get good internet from this one. Okay, anyway, don't worry about it. We go ahead with, okay, this figure has nothing to explain more. It's the same thing, okay. When they throw away the box actually doesn't happen, okay. They just put the box into this so that you can see the head and the tail of the magnetic field line, okay, so that you can understand. But actually it can also be seen as this figure, the figure 34, okay. It's not different at all, and that the force will take place in any location along the length of the conductor, along the upper conductor, okay. The force will happen everywhere, okay, as soon as you have magnetic field that is crossing the upper conductor, okay. The force will take place everywhere. Now let's move to the lower the next figure, in figure 44, okay. It's taken from a different book, okay. You may see some different notation, but actually it represents the same thing. Yeah. Zoom, right. Okay. Yeah, this is the figure that represent the same thing. Okay, the same idea. The force happened at the two parallel conductors. Okay, but this one, if we get into the detail, this will represent the force that happens to the upper conductor as well. Okay, but okay, now the current move in both conductors in the same direction. Okay, in the same way, from left to right. From okay, the upper conductor is denoted by number 1, and the lower conductor is denoted by number 2. Okay, the first and the second conductor. Okay, simply speaking, and it can be possible that the designer or the person who control all of this stuff will let the current flow with different value. Okay, that's why they say capital I with the subscript number 1, and here the current I, okay, with subscript number 2. Okay, it can be possible. Okay, it can be different value, and the distance between those two conductors is the d. Okay, in the magnetic field line that is significant. Okay, the important magnetic field line is the green one. Okay, is represented by the green circle here, and at this location, the dots, the black dot here. Okay, that's the position which is important. Okay, which is vital to us. Sorry, we're gonna make the analysis of the force view that will take place at this point. Okay, that's this at this dot line. Of course, according to the right hand rule, okay, the green one represents the magnetic field line caused by the lower conductor or the second conductor. Okay, according to the right hand rule, you can see that the magnetic field at the black dot position, okay, is gonna be directed out of the plane or in this direction. Okay, but they cannot draw it in 2D, otherwise it's not it doesn't include, so it doesn't include enough information. Okay, that's why they draw it in a different angle. Okay, this is the magnetic field. Okay, it's magnetic field strength actually, and they just say the subscript number 2. Do you know why? Why don't they say be with subscript 1? Okay, this is the magnetic field at the location of the first conductor. They should use the B with subscript number 1, right? But it's not the case, because this B, okay, the magnetic field here is caused by the lower conductor. Okay, it's the lower conductor. It's the second conductor, so that's why they write down here the subscript number 2. Okay, and we are gonna analyze, okay, or find the direction again. Of course, we are gonna use the same formula F I L B. โอเค ผมจะพูดไปเรื่อยๆนะครับ จะใช้สูตรเนี่ยไปเรื่อยๆ จนคุณซึมซับไปเองนะครับ ถ้าใครก็อย่าเพิ่งเบื่อไปก่อนนะครับ ใครที่ฟังแล้วไม่ค่อยเข้าใจก็มันก็ไม่มีอะไรนะครับ มันก็มีแค่นี้นะครับOkay, we use the typical formula FILB in order to find the direction first, right? Of course, the vector L in this scenario is gonna be in the same direction as the vector in the same direction as the current, right? The current okay, the current I1, okay, it's, we say that we are considering the length of the conductor at the section of L only. Okay, let's say the length of this conductor is L. Okay, it's the written style of the L letter. And yeah, nothing wrong, right? In the next vector, okay, the second vector to us is the vector B, right? We need to draw how the B vector points. Here we have the vector B, and it's in this way, right? And yeah, you have to turn your finger, okay, your 4 fingers from vector L to vector B like this, and the outcome or the result will be the direction given by your thumb. Okay, and this will be the induced force direction. Okay, and let's say this is the first force. Okay, the force that happens to the first conductor, the upper conductor. Okay, it's not too difficult, right? Okay, so now we go further to the, okay, you get to know how to determine the direction of the induced force already, right? But in physics, as I often say, there are 2 things. Okay, apart from the direction, we have to also take care of the magnitude, right? So it's time now to find how strong is the force. Okay, so the force of interest to us in that in the former page is F number 1, right? And from the basic formula we have seen in the previous top. Oh, sorry, it's not vector version. It's the scalar version. So it's I L B psi theta, right? Or psi phi, up to you. Okay, and yeah, we have to get into the detail. Which F we are considering? It's the F that take place at the upper conductor, so we need to write down the number 1 as the subscript for the force in this case. Okay, and yep, the detail for the first variable, force, okay, induced force, is already defined, right? Now let's move to the second variable, which is the variable I, right? Where is that? What I should we deliver to this formula? Of course, I should be related to the variable L, right? Which is the length of the conductor that we are looking at the current. Okay, so L should be the same one as the I, right? The I alphabet. So yeah, the I should be the L, vector L should be related to I here, right? And this I is I with subscript 1. Okay, so we write down here I with subscript 1. Okay, and L is only the magnitude, right? In this scenario, in this figure, it just simply say that we consider the same length of both conductors, so variable L will be the same for those two conductors. So we don't have L with subscript 1, L with subscript 2. Okay, simply L, okay, without any subscript. And B, let's talk about B in this scenario at figure 44. Okay, what about L? What is L mean? What does L mean in this case? Well, if we refer to the former case, when we would like to determine the direction, we just curve our four fingers from L to B, right? And ที่นี่มันจะใหญ่ไปนะครับ oh no 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 ขอเล็กหนึ่งเพื่อว่าคุณจะได้เห็นชัดนะครับโอเคthe B that is significant to us is the B is the magnetic field caused by the second conductor, right? So vector B here is the one that is caused by the conductor here I2, right? So the second conductor. So this B should have the subscript number 2. Okay, so that's why we can say it's B with subscript 2. But now we move to the fourth variable, okay, fourth term, which is psi theta, and of course the important variable for us is going to be theta, right? And you can see that theta in this scenario is the angle here is actually what color should I the green one? Okay, the angle here is right angle, right? So this one will be will give you theta of phi as 90 degree. Okay, and you can put 90 degrees to this variable, right? And nothing will be important for us anymore because sine of 90 degree is gonna remain or yield number 1, right? So that's the reason why they get the simple expression in equation number 40. Okay, only I1 L and V2. Okay, so with this analysis we get the simple result, which is I1 and LB2. Okay, I have delivered the detail already to you right now, how we arrive at the equation number 40, but it's not the final result yet. Okay, we have to go further. The additional analysis is that what is the magnitude of magnetic field B2? Okay, what is the value of B2 if we don't want the result like this? Okay, we want to really a deep detail on that, and we're gonna go back again to the figure number 44, and we will try to find the magnitude of vector B2 in this one. Okay, and you can see that B2 is the magnetic field caused by the lower conductor, right? The conductor, the second conductor. So we need to borrow the idea or the content from B.O. Sawad's formula, which is นักเรียนได้คะแนนเท่าไหร่คะไม่ได้เท่าไหร่ครับให้ Okay, and oh, yeah, yeah, we need to borrow the idea from Biot-Savart's formula, which is the formal topic is the formal topic known as the magnetic field caused by the lost-state copper wire, right? So you just brought the detail in the foil page, okay? But I can also write down the Biot-Savart formula again for this scenario. B2, right, is going to be mu 0I. If you can remember this one, okay, from the midterm exam or midterm test, mu 0 and 4 pi r, right? But r in this scenario is gonna be the distance, okay, the distance where both conductors are separated from each other. It's 4 pi d, right, instead of r, right? We get b2, which is mu 0I and 4 pi d. Oh, sorry, it's 2 pi, not 4. I'm stupid. 2 pi d, right? Don't get confused with that, because I am often aware that mu 0 is 4 pi times 10 raised to negative 7, right? So that's why 2 pi or 4 pi, but 4 pi is inside mu 0, okay? And yeah, I've got already the explicit sorry. We need to specify also the current, right? And the current in this one, okay, from the Biot-Savart formula is the current related to this one, right? Related to the second conductor or the lower conductor, right? So this I should be the current there, okay, the current here, okay. So we get I2 actually to the Biot-Savart formula. So we need to write down number 2 as a subscript in the Biot-Savart ratio fraction there, okay. Let's move to the slide, okay. I have already given the explanation why we arrive at equation number 41, right, from the figure. So if you have any unclear issue, just let me know. And then we will substitute 41 into 40, okay, in a straightforward manner. And of course, you can see that IRB, right? You put the value of b into this one, right? What happened? You put the value of b into 40 equation number 40, and you arrange something, okay. You move the เดี๋ยวขอเช็คดูก่อนนะว่าซูมมีใครขอเข้าอีกไหมเดี๋ยวผมไม่ได้กดรับเข้าแล้วคุณก็จะแย่นะครับโอเคครับไม่มีแล้วนะครับโอเคนะที่ซูมอยู่ประมาณ10 กว่าคนนะครับโอเคlet's go okay continue our story yep we need to arrange everything in a tidy way, okay. We need to manipulate everything. We move all the terms at the upper part at the numerator position together, so we get a good result to that. And the result will be the second equality in equation number 42, okay. It's mu 0 I1 I2, okay. Now we have both currents, okay. and L, okay, L is the length of both conductors that we are taking a look at, okay, and 2 pi d, 2 pi is a constant and d is the distance where the distance when both conductors are separated from each other, okay, all right, and that's the first force that happens or exerted on the first conductor, right? And you may have a question: what about the force induced at the second conductor? So what should it be, right? So I may not go completely into the detail how we arrive at the expression of the magnitude for the induced force at the second conductor, okay, but you just borrow the idea before, okay, how you get the force from the upper conductor, okay, in the same way, okay, and you can derive it in you get the force the amount of force exerted on the second conductor as well. But if you want, I can write it in the detail. It's no problem. Why we get equation number 43 okay ทำไมเราได้สมการ43ครับมันก็ไม่ยากนะครับ okay at the second conductors we would have the amount of force, okay, F2, right, at the second conductor will be ILB as well, right, but we don't need to write down sine theta anymore because the angle is 90 degrees, right? So we don't pay attention to the sine theta term. It's simply number one, but which I in this case, okay, if you take a look at the force, this is number one and this is number two, right? The force that will happen at the second conductor will be the current will be the result from the current itself, okay, which is I2, okay, and L is the same thing, right, because that's the portion of the conductor or how long the conductor, which will be the same amount for both conductors. So L in this one will be sorry, the current I, okay, the first variable will be I with subscript number 2, right, because we are considering the current because we consider the current at the second conductor, so we write down the subscript number 2. And what about B? B is the